All right, lesson 8.1 is adding and subtracting polynomials. And there are a whole lot of definitions in here, so buckle up and let's get ready. So first we have a monomial is a number, it's a variable, or it's the product of a number and one or more variables. There has to be whole number exponents. And I will give you some examples of monomials in a minute. Next we have the degree of the monomial is the sum of the exponents of the variables in the monomial. The degree of a non-zero constant term, so any number that's not zero, is 0. The degree of that number is 0. And the constant 0 does not have a degree. So here are some examples of monomials. We have monomial can be a number. It's the number 10. Well, this is a non-zero constant, so its degree is 0. A monomial can be the product of a number and a variable. We look at the variable, and this has the power of 1, so this is just a degree 1. A monomial could be a half a times b squared. Here's the number, and this is the product of a number and one or more variables. In this case, it's 2 variables. And it says that you find the degree by finding the sum of the exponents. Well, a has a degree of 1, b has a degree of 2, so when we add those together, this monomial has a degree of 3. And another one, negative 1.8 m to the 5. Here's our number, and the product of the number and the variable, and this is m to the 5th, so it's the degree of 5. Here are examples of non-monomials. A sum is not a monomial because a monomial is one term, and this happens to be 2 terms. Here, a monomial cannot have a variable in the denominator, so this is not a monomial. Another one, 4 to the a. The monomial cannot have a variable exponent. If you have a variable exponent, we're going to end up with an exponential function. And another one, x to the negative 1. The variable must have a whole number exponent, not an integer exponent. So when you have monomials that are hooked together by addition or subtraction, we call those polynomials. Poly means many, mono means one. So a polynomial is a monomial, or the sum of monomials. Each of these is called a term of the polynomial. And the degree of the polynomial is the greatest degree of its terms. So you look at all the terms, whichever one has the highest degree wins the degree of the polynomial. Like right up here, this is a polynomial. This is a monomial 5, this is a monomial x. You combine them and now they're a polynomial. And this one actually has degree 1 because the 5 has degree 0, the x has degree 1, so the x is the winner. Next, when a polynomial is written so that the exponents of the variable decrease from left to right, the coefficient of the first term is called the leading coefficient. And here's a little diagram. We've put this in order from left to right. So the leading coefficient is 2. The highest degree in this polynomial is 3, so it's the degree of the polynomial. And 12 is the constant term. So let us go ahead and put some of these in order. So my highest degree is negative 2x squared. So there's my first term, followed by a 4x, followed by a 3. The leading coefficient here is the negative 2. And it wants to know the degree, and this is a degree of 2 because 2 is the highest degree. Next, we have 4y to the 4th plus 6y to the 3rd minus 2y squared minus 5. So the leading coefficient here is the 4, and it also has a degree of 4. We have some special polynomials with certain amounts of terms, and the first one we have has 2 terms exactly, so we call that a binomial. The root bi means 2, like a bicycle has 2 wheels. A polynomial with 3 terms, I bet you can guess what means 3? Tri. A trinomial has exactly 3 terms. In the next set of problems, they want us to classify these. They want us to see, well, is this expression a polynomial? If it's not, tell why it's not. And if it is, tell the degree and classify it by the number of terms. So 10 to the x is not. The degree cannot be a variable. Negative 6n squared minus n cubed plus 4 is a polynomial. So we'll say yes. The degree is actually 3. You can't just look at the first term, you have to look at all of them. And this has 3 terms, so it's a trinomial. W to the negative 3 plus 5 is not. It does have 2 terms, but it's not a polynomial, so we can't call it a binomial. And it's not because the degree must be a whole number. And negative 3 is an integer. Okay, now we're going to find the sum or difference. Sum we know means add, difference means subtract. So what you do with these is you look from left to right. In between the 2 polynomials we have an addition sign. So now all you do is collect the like terms. So 8c squared plus a negative 3c squared is 5c squared. A lot of times I cross off the terms I've used. Negative 4c plus c is negative 3c, so I write it down as subtract 3c, and 1 plus 5 is 6, and we're done. If it's subtraction between the polynomials, you must take the opposite of every term in the polynomial that's being subtracted and then turn around and add it. So now it's just like the top one. 10b squared plus negative 4b squared is 6b squared. Negative 3b plus negative 5b is negative 8b. And 2 plus negative 1 is 1. Another subtraction, so I'm going to subtract or take the opposite of everything in the subtracted polynomial, turn around and add. I have a 3m plus 6m is 9m. 4 plus negative 5 is negative 1. I do have this leftover term here in the second polynomial, and that's a negative 2m squared. I do want us to put them in order from left to right. So I have a negative 2m squared, a plus 9m, and a minus 1. And the last one here is addition, so 2x squared plus x squared is 3x squared. 5x plus negative 5x is 0x, but you don't have to write that down. Negative 1 plus 7 is 6. So finding sums and differences. Last problem. Library books. For 1995 through 2005, the number F of fiction books in 10,000s and the number N of nonfiction books in 10,000s, so this is going to be key later, borrowed from a library, can be modeled by the 2 functions here, these 2 polynomials. T is the number of years since 1995. They want us to find the total books borrowed from the library in a year from 1995 to 2005. So we're going to go ahead and do that, and we're finding the total, so we're going to add them. Another method for adding polynomials is to stack the like terms, and that's what I'll go ahead and do here. And now we will add them. And when I add them, this is my results. I'm just adding the like terms. And that's the final answer for this, but suppose we want the total borrowed in 2000. Well, I have to understand then that my T is 5 because 1995 is year 0, so 2000 is 5 years later. So I'll go ahead and substitute, and that's what I did. I put the 5 in for the T, and now I'll go ahead and do my calculations. Remember that when you do this, you have to square first and then multiply. So this is going to end up giving us a 0.35 plus 0.65 plus 12. When I add that together, I get 13, but it's 13 10,000s. So really I'm going to multiply 13 by 10,000, and that gives me my final answer of 130,000 books that were borrowed in the year 2000. I do not have an assignment around for you yet, but I will give it to you on Monday. So your only assignment for this weekend is to make sure that you study for Chapter 7 test and take these video notes so that Monday after the test you can be prepared to work on this assignment. Have a great weekend.